Welcome to today's lecture. This is Transformer Part 2. In Part 1, we looked at the meaning of transformer. We said a transformer is an electrical device that is used to change the voltage of an AC supply. That is, it is used to either increase or decrease the voltage of an AC supply. Then we went ahead to look at the types of transformer. The step-up transformer used for power transmission, the step-down transformer used for electronic devices and at home. And then we looked at what we refer to as the turns ratio. The turns ratio, that is the number of turns in the secondary coil over the number of turns in the primary coil. We said if the turns ratio is greater than 1, then that transformer is a step-up transformer. If the turns ratio is less than 1, then that's a step-down transformer. If the turns ratio is equal to 1, then that's an isolation transformer. That takes us to what an isolation transformer is. An isolation transformer is a transformer in which the primary and secondary coil have the same number of turns so that the output voltage is equal to the input voltage, but the circuits are electrically isolated from each other. So our key points, NS is NP. So turns ratio is equal to 1. The voltage in the secondary coil is equal to the voltage in the primary coil. No change in voltage and works with AC only. Why is it called isolation transformer? Why is it called an isolation transformer? There is no direct electrical connection between the input and output circuit. Number 2, energy is transferred only by magnetic induction. This improves safety. These are the reasons why it is called an isolation transformer. So what are the uses of isolation transformer? 1, protection against electric shock. It protects against electric shock. Number 2, servicing and testing electrical equipment. It is used for servicing and testing electrical equipment. Number 3, noise and interference reduction in circuit. It is used to reduce noise and interferences in circuits. This will take us to efficiency of a transformer. The efficiency of a transformer is given as output power over input power times 100%. And you can also say power output over power input times 100%. Our power output or output power is ESIS, while our input power is EPIP. You need to commit these formulas to memory. This will take us to energy losses in a transformer. Energy losses. What causes energy losses in a transformer? That's what we want to look at now. Number 1 is what we call heat loss, or what we call copper loss. This is due to heating of coils when current begins to pass through the coil. And what is the remedy for this problem? It is reduced by using thick copper wires. By using thick copper wires. Number 2, energy loss, eddy current loss. Eddy current are actually circulating current in the core that is produced as a result of the changing magnetic flux going through the soft iron core. So how do you reduce this? It is reduced by laminating the core. It is reduced by laminating the core. Hysteresis loss. Hysteresis loss is as a result of the repeated magnetization of the core. The repeated magnetization of the core, and this is reduced by using soft iron. And lastly, magnetic flux leakage. This is caused by poor core design or imperfect alignment of coil. And how do you reduce this problem? By using an efficient core design. By using an efficient core design. We want to look at the reason for laminating the core. What are the reasons for laminating the core? Number one, to reduce eddy current loss. Number two, to increase the efficiency of the transformer. These are the major reasons why the core should be laminated. Why is it that soft iron is recommended? To aid easy magnetization and demagnetization of the core, and to reduce hysteresis loss. These are the two reasons why soft iron should be used. You could be asked, why soft iron? So soft iron is used to aid easy magnetization and demagnetization of the core, and number two, to reduce hysteresis loss. Uses of transformer. Number one, it is used for power transmission, that is the step-up transformer. Number two, for power distribution to homes, that's a step-down transformer. Number three, used in radio and television, that's television circuit, that's also the step-down transformer. Power transmission. Power is transmitted at high voltage and low current in order to reduce energy loss in transmission cable. Energy is lost, or the energy lost is usually as a result of heat in the wires due to their resistance. So in other words, power is transmitted at high voltage, a low current. Now, the reason for this is because the cables through which power is transmitted have resistance. And if power is transmitted at high current, it will lead to a large amount of energy loss as a result of heat. To prevent this, power is therefore transferred or transmitted at high voltage and low current. What are the advantages of transmitting power at high voltage and low current? Number one, less power loss in transmission lines. That means if you transmit power at high voltage, there will be less power loss in transmission lines. Number two, higher efficiency of transmission. So it leads to higher efficiency of transmission. Number three, thinner and cheaper conductors can be used. That means you can use thin and cheaper conductors. Number three, electricity reaches consumer within minimal losses. So what's the summary here? That power is transmitted at high voltage and low current to minimize heat loss in transmission cables. I will see you in part 3 where we look at numerical problems.